So today what we're going to talk about is stuff to do with circular motion. So I noticed on some of the problems that there may be some confusion on some concepts, so I'm going to try to make these clear so that you don't miss any easy problems. So first we're going to start off with the direction, magnitude of force, velocity, and acceleration while they're in circular motion. So I'm going to draw a circle right here, and this is going to be our circular motion. It took 4 attempts at a circle, I'm well aware, but nonetheless, if we have our object here, the velocity, the direction of it will go out this way. So the velocity vector should go this way, and it's the tangential velocity. So if we have something spinning in a circle, the velocity is always tangent to the circle. So it's always going to go off in a line.
Teachers, once you have taken attendance, if you will check for any students that have an orange ticket to the Texas Invitational basketball game today, and if you would send those students with the orange tickets to the Cotton Watkins gym. Again, this is only the students that have purchased the orange tickets to the Cotton Watkins gym. Thank you.
All right, sorry about the interruption, but I don't feel like re-recording this. So, anyway, the centripetal force on the object and the centripetal acceleration will be directed toward the center. So the centripetal force as well as the centripetal acceleration will be directed toward the center of the circle. And it doesn't matter where this is. It doesn't matter if it's here, or if it's here, or if it's here. The tangential velocity will always be directed in a line tangent to the circle, and the centripetal force and the centripetal acceleration will be always directed toward the center of the circle. So regardless of where you're at, they will all be directed toward the centripetal acceleration, centripetal force, always directed toward the middle. Velocity is always going to be tangent to the circle. The force and the acceleration will have a magnitude that remains constant. So the magnitude is constant on all of these. So on every single one, the magnitude will be constant, meaning that the number that they have, I know I'm no longer in the frame, but the number that they have, say 4 for force, 4 newtons, wherever it is in that circle, the magnitude will stay 4. But the direction will change. As you can see here, it's directed inward to the circle, but it's up. Here, it's to the side. Here, it's to the other side. The tangential velocity changes as it goes around the circle. At the bottom, it's going to the right. At the top, it would go to the left, right? So it doesn't matter. It doesn't matter where it is. The magnitude will stay the same, but the direction will change. And so that's important to keep in mind when you're answering questions. All right, next, let's do some looking at what happens when we change things within the formula. So one of the things that's really popular to do in physics classes is to change variables and say what will happen if I do this. So let's look at the formula for centripetal force. So it's mv squared divided by r. So let's start by saying that, just like we did with the gravitational force, that everything starts off as 1. So 1 is equal to 1 times 1 squared divided by 1. So this will be our baseline of 1, obviously. So if I change, let's say I change the velocity. So let's say I multiply the velocity by 2. So now I have 1 is equal to 1 times 2 squared divided by 1. Actually, this would change, right? The force would change. And you would end up getting 4 for your force. So you'd have 4 times greater force. So if you double the velocity, you get 4 times greater force. How about if I double the bottom, right? If I double the, like you're walking right in front of the camera. So if I double the radius, the distance, then this becomes half, right? So instead of 1, I get a half. Alright, let's look at what happens to the speed if the force gets changed. So now the velocity stays the same, and I'm going to change the radius, and the force will stay 1. So 1 is equal to 1 times v squared, and then I'm going to double the distance. I'm going to keep the same force on it, but I'm doubling the distance. So what would happen? I plug a 2 in there, multiply the 2 up to get rid of it, square root, and 1.41 is equal to v. So if you were trying to figure out what the relationship would be, if I keep the force the same, then the velocity has to increase, right? Because here, if it's 1 times 1 times 1 squared divided by 1, we would get 1. In this case, if you put a 2 down here, the velocity has to be 1.41 to make up for it. Okay, so I've tried to show you different things on when you change variables. Basically, just plug them into the formula. Whatever it says to change it by, make everything else 1, plug that into the new formula, and see what happens, okay? That's the best method of doing this. Whatever you get as your answer is usually what you have to multiply the old number by to get it to where it is. So in this case, we got 1.41 times. That means that you need to multiply it by 1.41. Okay, next thing, circumference. The circumference of the object, this may not be apparent until you hear it explained to you, but it should become apparent afterwards. So if we take a circle, alright, and we're looking for the velocity of the object going around the circle. Well, first of all, you need a time. So you should be able to find the time most of the time. I will either give you the time or it will be somewhere in the problem. You may have to think a little bit about it, like it might say if the moon rotates around the earth in 28 days. Well, you can figure out the time by using that, right? 28 times 28 times 24 times 60 times 60 will give you the seconds in the day, all right, or the seconds in the month that it takes the moon to go around the earth. But the circumference, the distance, may not become apparent. So that's the reason I'm explaining this to you. The circumference of the circle becomes the distance for circular motion. So we know this formula, v is equal to d divided by t. This is our general formula for speed. But whenever we're talking about circular motion, right, you're not going in a straight line anymore. You're going in a circle. So if I give you the radius of the circle, you should be fairly capable of finding the distance that it goes by using your what is it, geometry map of circle is equal to 2 pi r, right? So that becomes your distance. You now have a distance. You probably have a time, all right, and you can figure out the speed of your object now. And then once you figure out the speed of the object, it can very easily move into your other stuff. So once you find the speed of the object, you can find acceleration, you can find the force, all that good stuff. There are a couple of questions that deal with period. So the period is quite simply the time it takes to make a circle, right? So if you start here and come around, right, the period is the time to complete one rotation. Alright, so that's really simple. So however long it takes to make one rotation. And then the last thing I'm going to talk about is different planes of the circle. So when we did the lab, if you'll remember, we talked about how we had two different forces. We had forces in the y and forces in the x. Well, in the helicopter lab, we had the circle going around in the x direction, and the force of gravity was coming down in the y direction. So we had a centripetal force that was in the x, and the force of gravity was in the y. The centripetal force only acts on that one plane in that case. So that's the centripetal force on that. It was only in the x direction. There was no other stuff acting in the x direction other than the tension. So the tension had a component in the x direction and a component in the y direction. But the x component was all we cared about. That was the only thing acting on it that mattered. So if we looked at a Lazy Susan, say, and we put a boat of gravy here on the end, and we're trying to figure out the force of friction on it. Well, the only force acting on this object, if it's spinning in a circle, the only thing acting on this object would be what? The force of friction. So the force of friction would be pushing it inward, keeping it into the circle, and the force of friction, since it's the only force, and the net force is equal to the centripetal force, those two are one and the same. So if you found the centripetal force, then lo and behold, you found the friction force. However, the horizontal ones are the easy ones, because usually there's only one thing acting on it. But the other ones are a tad bit harder, so you may have to think a little bit longer on them. If they're swinging vertically, remember that not only do you have the tension or the force of the string acting on it, you also have the force of gravity. So there's two things involved here that you'll have to take into account. Alright? So I hope this has helped you. Hopefully you've enjoyed your Thanksgiving, or you are about to enjoy your Thanksgiving, and I will see you on Monday.